Ignition sequence start.
Good morning. You've got a great view here inside the International Space Station Flight Control Room, where the members of the Orbit 2 team of flight controllers are keeping tabs on the space station's systems while working with the Expedition 63 crew members as they get set for a big change. Commander Chris Cassidy and his Russian crewmates are working alongside their SpaceX Crew Dragon crewmates as they get closer to finishing up their demonstration mission at the station and starting the last phase of their flight with a journey back to Earth.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla France. This week, the crew is keeping busy with science before parting ways. NASA astronaut Bob Behnken was spotted conducting the droplet formation study in the station's microgravity science glove box to show that science results can be for everyone. This investigation by Delta Faucet through the ISS National Laboratory evaluates water droplet formation and its movement through different technologies. The research is aimed to improve faucet technology, creating better performance and improved user experience while conserving water and energy. The crew also spent the early part of the week performing the checkout of the Astro B robotic system. The Astro Bs, 3 cube-shaped robots, are designed to aid the crew in common tasks aboard the station. But first, they will play a part in JAXA's upcoming Kibo Robot Programming Challenge in the fall. Using fans to move and cameras to see, the Astro Bs will help pave the way for the robotics that will be used as we go back to the moon and on to Mars. With the science complete, crewmates Bob and Doug set their focus on their return aboard the Dragon Endeavour, concluding their 2-month stay on station. The Crew Dragon vehicle will autonomously undock with the 2 NASA astronauts on board, depart the space station, and re-enter the Earth's atmosphere. Upon splashdown, just off Florida's coast, the crew will be picked up at sea by SpaceX's recovery vessel and returned to shore, where they'll be flown back to Houston to reunite with their families. Be sure to join us and follow along with NASA TV. Complete mission coverage will start prior to undocking and will stay on the air with continuous coverage until after splashdown. Keep sending in your questions using the hashtag AskNASA. We'll see you next time.
SpaceX's Demonstration Mission 2 is the first flight of NASA's Commercial Crew program to carry astronauts to space. Here are 2 more of our Commercial Crew astronauts with an overview of the program, including a peek at the trip awaiting Crew Dragon Endeavour when it plows through the atmosphere headed for home.
NASA's Commercial Crew program is ready for launch. Did you know the last time we launched astronauts from America was in 2011?
NASA is working with companies Boeing and SpaceX to take astronauts to the International Space Station from America once again. Let's look at how this will happen.
Look at the spacecraft on top of the rocket. This is where humans will be sitting. The astronauts will be buckled into a spacecraft, stacked on top of the rocket as it is launched into space. The rocket holds all of the fuel needed to get to space.
It takes a lot of energy to lift the rocket off the ground, with gravity constantly pulling it down, which is why most of the rocket is filled with fuel. During the rocket's climb to space, it will increase in speed, which means its energy will also increase. Once the rocket has made it past Earth's atmosphere, the engine will finally cut off. The rocket and the spacecraft will separate, and the astronauts will make their way toward the station, where they will be working on science experiments and engineering projects.
What do you think will happen when the spacecraft travels back to Earth?
Boeing has made the Starliner CST-100 to keep astronauts safe as they travel to and from the station. It's designed to touch down safely on land in the western United States. The Starliner has parachutes it will use as it prepares for landing. but will also have large airbags expanding under the spacecraft to cushion the landing for the astronauts before stopping completely.
SpaceX's Crew Dragon was also created to send astronauts to and from the space station. As the spacecraft comes back to Earth, the outside will experience temperatures over 3,000 degrees Fahrenheit. The Crew Dragon has been designed to keep the astronauts inside comfortable during their ride home to Earth. Once they are back in the atmosphere, the spacecraft will release 4 main parachutes to slow down the speed and energy of the vehicle before it splashes down in the Atlantic Ocean or Gulf of Mexico. These spacecraft are exciting sneak peeks at the future of space travel.
And NASA's Commercial Crew Program.
Want to know more about space travel? Check out this website for more information.
The Commercial Crew Program is one part of the growing commercial space economy, which the International Space Station has been encouraging for some 20 years now. The expansion of the commercial use of space not only fosters growth for those companies, it's also aiding NASA as it continues to explore and discover what's out there beyond low Earth orbit.
Those striving to develop their products and conduct research beyond Earth's atmosphere are seeing their visions come to life through the International Space Station National Lab and partnerships with NASA. NASA, in turn, is gaining new resources to aid in its mission of exploration and discovery. Thanks to these partnerships, the world is benefiting from the ingenuity of those who are taking their ideas to gravity's edge. From transportation to satellite deployment to in-space research, a vibrant commercial space economy has been developing, and its value now exceeds $345 billion. Mike Reed is the manager of the ISS Business and Economic Development Office at Johnson Space Center. He explains some of the benefits of NASA investing in the commercial economy in space. Commercialization of low Earth orbit frees up resources NASA needs to continue its exploration of space. Even as NASA prepares to return to the Moon, go to Mars, and continues engaging with other space missions, we'll always need a platform in low Earth orbit. That platform enables crew training, advanced systems development, and fundamental and applied research. But expanding use of the space station to commercial companies enables a new market. By having the commercial sector join us, we can continue our space exploration while providing access to a platform that helps create jobs, build revenues, and ultimately create many new products that are beneficial to people on Earth. In terms of research, many companies are making use of the ISS US National Laboratory to run their research and technology development investigations in microgravity. They include well-known corporations like Procter & Gamble, who have used the station to study colloids with a goal of improving the quality and lifespan of their products, such as shampoo and laundry fabric softener. Merck, the multinational pharmaceutical company, uses the National Lab to study the growth properties of three-dimensional protein crystals. Their work could lead to more effective delivery systems for cancer treatments. Even companies not as well known right now are seeing big dividends coming from their research. Lam Division, for example, is using the microgravity conditions on the station to advance the development for treating the effects of retinal degeneration, with the goal of restoring the vision of those people affected by it. In addition to research opportunities, the space station contributes to expanding the space economy in other ways. Reed explains, the capabilities of launch providers such as SpaceX and Northrop Grumman have grown dramatically over the last decade. The cost of placing cargo into orbit has dropped dramatically, which opens up the space marketplace to many more non-governmental entities who simply could not afford the costs of reaching space before. Now, SpaceX has brought astronauts to the station from American soil for the first time since 2011, and the first time ever on a privately owned launch system. The Commercial Crew Program provides a huge long-term benefit for both private companies and NASA. Today, thanks in part to the space station, commercial and other non-governmental entities are entering the space economy in significant numbers. What these new partnerships can accomplish together will drive the in-space marketplace and NASA's grandest missions to new heights, as well as improving quality of life for people on Earth. For more science and research from the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
The International Space Station has given us 20 years of promoting commercialization of space, advancing space research, and providing a platform to test and perfect a new fleet of vehicles. The knowledge we continue to gain from this orbiting laboratory is vital to our future in space.
The International Space Station, a football field-sized, million-pound laboratory flying around planet Earth at 17,500 miles per hour. It's our home in low Earth orbit and the bridge to exploring the far reaches of our solar system. A place to learn what it takes to live, to work, to thrive in space. Thanks to space agencies representing more than a dozen countries around the world, it went from the drawing board to liftoff when the first piece flew into space in 1998. That kicked off over a decade of construction, hauling the station to orbit piece by piece on NASA's space shuttle and Russian rockets. And after the first crew arrived in November 2000, we started an unbroken streak of humans living and working in space. Building on the legacy of past outposts like Skylab and Mir, the International Space Station became the training ground for humanity's next great journeys. Learning how to live in space for extreme periods of time, building and perfecting the technologies necessary to travel to our neighbors in the solar system. It gave us a place right on our doorstep to prepare for the next giant leap into the unknown. And thanks to the station, a new era in outer space is unfolding. What was once the domain of only nations and governments is now populated by a growing space fleet from American industry. Private spacecraft to fly cargo and crew members, new habitats and technologies for future space missions, and an open door for companies, research institutions, and even students around the world to do research in space that have never had the opportunity before. All laying the foundation for a robust economy in space. There have been thousands of experiments, hundreds of spacewalks, endless hours of challenges and successes, all done by humans hailing from countries around the globe. The International Space Station is what we can achieve as a planet when we come together to do the things that are hard. And the work isn't slowing down, because we're ready for the next giant leap. Because we're ready to go farther. Because what we do and learn along the way is for the benefit of all of humankind.
Come this November, we will mark a full 20 years that there have been human beings living and working on the International Space Station. Those people represent 19 different countries. The most recent addition to the list coming when Hazza al-Mansouri of the United Arab Emirates floated aboard last fall. Al-Mansouri says he has a new perspective on the power created when the nations of the world work together in space.
Recently, our country opened this opportunity to participate in a space program and to be part of international cooperation, to be part of the ISS. So I applied. And then through my journey, I've been selected and I've been fortunate to represent my country and also the whole Arab region because I will be the first Arab on board the station. I read about Yuri Gagarin and Neil Armstrong, how they achieved their dreams and how they really reach the moon at that era. And then all of these things started the passion in me that I want to be part of this. I want to reach beyond the sky, to reach stars. Sitting at the top of the rocket and waiting for countdown, going to stars, and to join a lead team on board the station, doing science, doing something for humanity. It's really something incredible, something that you want to tell it to the next generation. If you ask me like 2 years ago, can you be an astronaut? I will tell you I would like to be, but I think it's impossible. But now it's possible. What we did in our country and in our region after this mission is really impressive in terms of igniting the spark in the next generation. This is our job as an astronaut to let them know, to give them the experience that what we saw, what we experienced on board the station. You cannot experience here on Earth, from microgravity, from floating, and the view of the Earth from there. It's really amazing. It's something that's overwhelming. Looking at Earth from that angle, it's different angle, different perspective, and you come back with appreciation what you have here on ground. I landed in Kazakhstan, but I felt like I'm back home. So despite the country that you land, you come back to your home, to our mothership, to our planet, to Earth. It's amazing how space unites everyone, despite from which country you're coming from, or from your religion or your background. It unites everyone. So it's really important to focus in this aspect and to focus in this front to exploring space, because somehow everything is dissolved. All these political issues, all borders dissolve. Despite from where we are coming, like from which country, our backgrounds, our religion, our objective is one, is for humankind.
One goal of the International Space Station is to help get us ready for future missions beyond Earth orbit, to the Moon and out into the solar system. The Artemis program is making progress preparing the hardware that will support those missions, from new testing on the Orion spacecraft to building the elements of the Space Launch System rocket and the systems on the ground to support those launches. Here's a quick look at what we've been up to lately. NASA's Artemis program will expand on the achievements of the International Space Station and open the door for humanity to live and work sustainably on another world for the first time. First the Moon, and then on to Mars. Actress Kelly Marie Tran tells the story of how we are going to put the first woman and the next man on the Moon by 2024.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the Moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
If you'd like to get another look at any of these stories you just saw today, go to YouTube or Facebook. There are the addresses. And when you're there, be sure to take a look around, because there is a lot of other cool stuff that you'll find about NASA and America's human spaceflight program. Now, if you're interested in good conversation about human spaceflight and space exploration, check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today Gary Jordan talks with two of the engineers developing the new tools that astronauts will use when they make moonwalks during the Artemis missions. Go to nasa.gov/podcasts for this week's episode. It's where you'll also find all the previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. Thank you.